Okay, hello everyone. Thanks for being here. This presentation is about Ceph and OpenStack and how we can deploy Ceph. Can you hear me? Can you hear me? Holding me okay? Should I speak louder or no? Okay, good. So we're going to spend the next 20 minutes explaining what's the state of the integration of Ceph into OpenStack, what has been done during this Juno cycle, and we will also touch a little bit about how to deploy Ceph by using Ansible. So who am I? I'm Sebastian and I work for Innovance. Innovance is a Red Hat company. So as you might already know, Innovance has been acquired by Red Hat quite recently. So basically you can reach me at seb@redhat.com, and well, pretty amazing, right? I got the aliases, so that's pretty proud of it. I'm a cloud architect, so I basically build, design cloud platforms. So this involves compute, storage, and networking as well. My main domain of expertise are OpenStack and Ceph, obviously. So, well, this is my personal blog, and this is Innovance blog. Don't hesitate to check them out. We have tons of really good articles. So let's start by OpenStack and Ceph and well, what has been done into the Juno cycle. Just for you to know, the Juno cycle is not over yet, so that's going to be, well, I think we still have 1 month and a half or something. I think we already reached Juno 3. So many things have been implemented and things are ongoing work. So obviously one of the best things is Defstack F. So I struggled during 7 months to get this patch done into Defstack, but I'm pretty happy because that will definitely improve the way we work, the way we code, and the way we can implement new things into OpenStack with Ceph. So basically, if you just git clone the latest version of the Defstack repo, you can just put a local RC. I have an example on the next slide, and it will basically configure Ceph cluster, will configure Glance, Nova, Cinder, and even Cinder backup with it. So I'm not sure if it's quite readable, but I will send the slides later. This is an example of a local RC. The most interesting flags are, of course, this one, enabled services, Ceph. You can specify many options defining how big the cluster should be, 10 gig, or by default it's 4. A path for the configuration file of Ceph. If you want to play with the Ceph replication, you can also say, okay, I want 1, 2, 3 replicas. And I believe that's it. Yeah, you can also name the pools and the user that will access the pools. So that's everything has default values, so don't need to be that much detailed. So now what has been implemented into OpenStack, because Defstack is not really inside the OpenStack. On Nova, we now have the support on copy and write cloning. To give you a little bit of background, by default when you boot a VM, you need to, the default process is Nova compute, contacting the Glance service, and then ask for the image. So it will download the image locally, and then it will boot the VM. Prior to this patch, the behavior was more or less the same, but the main difference that we were still fetching the image from Glance through the compute node, and then we had to import the image into Ceph, which was really inefficient. So that's why we ended up using the copy and write clonings, because RBD images, well, snapshots from RBD images support cloning, so we can just do a copy and write clone. So basically everything is happening now everything is happening at the Ceph level. So when you decide to boot a virtual machine, if the image is already living in Ceph, so Glance, Ceph used as a backend for Glance. As soon as you upload the image gets snapshot, protected, and then when you want to boot a VM, we just do a copy and write clone. We just trigger the KVM process and we just simply attach the link to the block device. So in terms of, well, and the good thing about this is that booting a virtual machine is extremely fast, so it's just within a second basically, because doing a copy and write clone is just really snappy. So first thing, it's really fast, and it's really efficient as well in terms of space, because using copy on write clones, well, is really efficient by default, because everything is referred to the parent image. So everything, as soon as you want to perform a new I/O, if the file that you want to access is already in the parent image, just read from the parent image, and you just write what needs to be written, basically. Nova as well. So we definitely needed to improve the way we were doing the live migration. By default, Nova assumes that, well, actually it looks for both shared storage. When you ask for live migration, the code assumes that both destinations already exist, because you use shared storage. So it will just check if the directory of the instance is already present on the destination compute node, and if the libvirt.xml is already there too. And in our case, it wasn't there, because it's not distributed file system shared storage, but it's shared storage by using block devices. So this checks failed, and then we ended up running back to the block migration. So we had to move everything byte by byte, so that wasn't really efficient. Now we needed to distinguish two things. Is it shared storage, and is it shared folders? So if the folders are shared, then it's live migration. But we can also have the case where we use Ceph, and it's not shared storage, it's not shared directories, but it's shared storage, because we have the exact same entity that is managing all the devices. So we added a second check, and basically now if you use the option is called in Nova is image backend. If you use the image backend RBD, then the live migration code knows that you're gonna, well, it will have to trigger live migration, because both destinations are already known. In Nova as well, use Ceph cluster stats to report disk usage. By default, the Nova Compute process reports many metrics, like what's the amount of memory currently being used on my compute node, how many vCPUs are already used, and what's the storage being used. Because by default, when you boot a VM, the root disk of the VM will end up being a file on the file system that will live under var lib nova instances in instances ID. So basically, the Nova Compute process is just scanning this partition, can be a partition, or just scanning the file system, and then it reports the available size, which in our case wasn't true, because we are using Ceph, and what we are reporting is the size of the file system and not the size of Ceph. So at some point, if you were using well, a capacity-based filter for booting your virtual machines, then you will end up with many errors, because probably your partition is just too tiny. We also store config drives in Ceph. And just for you to know, at some point within OpenStack, you might want to create networks, but you don't want to enable DHCP. So basically, we needed a way to tell the instance all its metadata, so hostname, IP, DNS, and everything. Since you don't have any DHCP, you can't reach the metadata server. So now what's happening is that during the boot process, the compute process creates a tiny image. It's like a floppy drive, fat drive, where it puts all the metadata, like once again hostname, IP, DNS. This disk will be attached to the KVM process, and then it will appear as a second device on the file system. Then if you had the proper Cloud Init configuration, the Cloud Init will just open and mount this partition and read all the metadata, and then do the rest. We configure the IPs and things like this. So you want to do static routings, routing for example, that's the way you should do it. The problem was that we have the disk living in Ceph, and we have the config drive that wasn't living in Ceph. So when you want to trigger a live migration, then you can't, because at some point the code detects that you actually have a shared, you're actually using a shared storage. So for the main partition, the rootfs of the instance, but the config drive is not living in Ceph. It's part of the local file system. So one needs live migration and the other one needs block migration. So everything was broken. Now the config drive is also stored into the into Ceph. So that's live migration is not broken anymore. On the Cinder side, really tiny. Had stripe size for stripe, not strip, size support for the RBD driver. It's basically when you create a new RBD volume or image, whatever you want to call it. You can define a different stripe size. By default, it's 4 meg, because you can go to 8 or more, and so that's that should probably improve some of your workloads if you use a bigger stripe size. So what has been implemented. This might doesn't look that much, but just for you to know, this patch and this patch, well, individually almost 400 lines, so that's a lot. A lot of time is spent to review and going back and forth, so that takes a lot of time to get such features merged. So actually, for me, it's a really big improvement for Juno. We definitely needed this one and this one to have a proper environment running. What's in progress? Since Defstack F is here, now we can just enable Ceph within the gate. So just for you to know, every time you send a new patch set into OpenStack, into Gerrit, we have what we call the gate, where it's just a CI that bootstraps several Defstack virtual machines with different capabilities, maybe for VMware, maybe for Neutron oriented, and then we can have something for Ceph. So as soon as you push a new patch set for Ceph, the new patch will be tested against the Ceph CI, so we ensure that we don't break anything, because, well, you know how it is, I guess. We had a new feature, but in the meantime we also create a new bug. So we just try to minimize the effect. So that's in progress, and that's definitely going to be for Juno. We also need to fix the Nova evacuation. The Nova evacuation is the only way to provide a good disaster recovery feature for the OpenStack environment, because as you might know, there is no HA functionality for the virtual machines within OpenStack. So if a compute node goes down, well, all the VMs that were running just die as well. So basically what you can do is, if the compute node dies, you just do a Nova evacuate, and this will just respawn the VM on another compute node. Using Ceph and shared storage well, we can really benefit from that here, because we won't lose any data. Well, not much, maybe. Maybe some IOs will be lost during the crash, but we will have the exact same environment on another compute node. And once again, the evacuation is really fast, because we just need to spawn a new KVM process on another compute node and then reattach the block device on that KVM process. So actually, this is not a big thing, but it needs to be fixed. So that's in progress. Unfortunately, things that have been postponed to Kilo. Cinder, we still don't have the ability to migrate Cinder volumes, because within Cinder, well, a couple of releases ago, they introduced a new feature called the multi-backend. So you can define a volume type per backend. So you can have a NetApp backend that the type is called NetApp, and then a Ceph backend. And ideally, you will be able to migrate from NFS to NetApp and the other way around, NetApp to Ceph and the other way around, because maybe one is super fast and one is a little bit slower, and then you get built differently. We still can't, well, most of the code is already there, but just the same as this one, we missed some spec freeze, and then we just can't get it into Kilo. So we will just continue the work during the Kilo cycle, and that is likely to be implemented in Kilo. For Nova, we when you take a snapshot, basically we use QEMU, and it's just a flat snapshot, so it's a complete snapshot. We don't do any incremental or anything like this. So basically the snapshot goes locally. So when you do the snapshot, it goes through vallib, libvirt, snapshots, something, and then it gets re-imported into Glance, and then goes into Ceph again. So that's not really efficient, and if you only have a 1 gigabit network, 1 gig network, that might be quite slow to perform this operation. So that's why we would like to implement the snapshots at the RBD level, because RBD volumes support snapshots, and so if we can do this, we don't need to go through from the compute node to the Glance and then to the Ceph again. What is good as well is that it's a major problem for, I believe, public cloud providers, because when you take snapshots, well, if you just want to start with Ceph and then you just think, okay, everything will be living in Ceph, so I don't need any space on my compute nodes, so I would just go with 146 gig for my rootfs disks for the compute node, and then all of a sudden you have many users that start to do snapshots. And of course you need this, you need a temporary space to store the snapshots before they get uploaded into Ceph. So that might be a little bit tricky for the time being, but just keep that in mind, that you actually still need, and you can't do diskless compute node yet, but you need to save some space to perform your snapshots properly. So that was it about OpenStack, and now I'm gonna explain a little bit what I've been doing with Ansible and Ceph. I did the announcement when we were at the previous Ceph days in Frankfurt. I don't exactly remember when it was. I think around April or something, maybe. Really don't remember, but anyway, this was 6 months have passed, and many things happened into this repository. So well, I feel pretty proud of it, and I'm really happy to see that this repository has been getting many tractions from many users. So this is good. A little bit about architecture supports and Ceph version supports. So the Ansible can deploy and have been tested and proven on Debian with Ubuntu, both LTS, CentOS 7, Fedora 20. You can ask the Ansible playbook to deploy any stable version of Ceph, might be Emperor or Firefly, whatever. If you want to do some testings, you can also provide a branch from the Git master repository. So maybe you want to try the work in progress super fast IOs for SSDs, whatever, and then you can try this one, fast SSDs. And it also supports all-in-one deployments, so you can just bootstrap one node with even one disk. It's more testing, a testing scenario, but it's supported as well. So what can it do? Well, actually deploys monitors, OSDs, MDS, Redis gateway. You can also use HA proxy to balance all the requests. So I would say it's default. Tons of I recently added many Ceph settings that have proven to be extremely useful, like the ability to disable in-memory logging, which tend to improve performance a lot, and well, many Ceph settings that are quite important for running a Ceph cluster. It's Vagrant friendly, and as for the providers that are supported, we support VirtualBox and VMware Fusion. So we have also several OSD scenarios. When you deploy your cluster, you can specify that I have one disk and I want to collocate both journal and OSD data on the same disk. So I would just create a tiny partition at the beginning of the device, and then the rest we go for the OSD data. Then we have a second scenario where OSD data and journals are separated. So I have one journal, I have n OSDs, journals for one device. So let's say I have journal, well, OSD 1, 2, 3, and I have SSD 1, and then that's what's gonna happen. The third scenario is more an extension of the second one, because you can have multiple OSDs and multiple journals. So maybe you have OSD 1, 2, 3, their journal will go to SSD 1, OSD 4, 5, 6 will go to SSD 2, and so forth. So that's really flexible. We also support OSDs and journals on directories. Let's say you only have one server and you only have one disk, but you want to try Ceph as well. You don't even need to create a loopback device. Well, you can, but it's not needed. You can just reference the directory path where you want to have your OSD deployed, and you're done. So for servers with limited capacities and also limited in disk, that's quite useful. Going further, I also wanted to provide more extensions to the playbooks. So now if you're not really familiar with Ansible, at least there is a tiny bash script that can install Ansible for you and supports many distros. There is a rolling upgrade playbook from which you can just say, okay, I want to go from this version to another version, and then we just upgrade everything in a rolling fashion. So that's quite good. I also added a purge playbook that goes through all the OSDs, removes all the data, and deletes all the partition and everything. So actually, I've been using a lot of this functionality while deploying new clusters. When you do performance testing, for example, you can quickly deploy a cluster with one of the scenarios that I mentioned for the OSDs, and then you can quickly purge the Ceph cluster and recreate one. So that's everything can happen really fast. So you don't spend any time deploying and destroying your Ceph cluster. You can just focus on what you're doing, benchmarks. Okay, so as well, just a little example. As I said, it's Vagrant friendly. So you just clone the repo, just do Vagrant app, and by default you will get 3 monitors, 3 OSDs, and run Rados gateway virtual machine. A little bit about the roadmap. I like to move everything into Ansible Galaxy. Ansible Galaxy is a collection of roles that you can use individually. So if you have a central Ansible repository on your platform, you can just grab one role and then use that role into your playbooks just to extend what you can do. So actually everything is ready and everything is already Ansible Galaxy friendly. I just need the time to put them on the Galaxy. And I like also to rename many variables for consistency, because we have many variables now, and what I like to do is to have a role name as a prefix for every variable. So once again, it's nothing, but I just need time. There is a huge refactor that is going on the YAML syntax, and apparently is about to get merged pretty soon too. So not that much about the roadmap, because I believe the playbook already does many things, and probably way more than the Ceph and the Puppet can do at the moment. So that's it. Merci, and thanks for your attention, and I'll be happy to take questions, because we still have 5 minutes, so fire it up.